Next thing we're going to do, which is a very big part of Java, is making variables. Over here in your note sheet, variables, which are also called fields in Java. But for right now, very basic program, we're just call them variables like in math, where it can store something, the variables that can store something. The Java conventionalities are any letter, number, the underscore, or the $ can be used. So let's go over here and make a variable. So we're going to make a variable, and you have to tell me what kind of variable it is as well. So I'm going to say int, and then I'm going to come up with a variable, and maybe I call it dog. Int dog is declaring a variable, and I'm going to put a comment there. This is declaring a variable. What I just did is opened up some memory location to be able to make it. So what happened just in the computer by doing int dog, just as a quick reminder of this, and I'm going to fumble through this a little bit, is we just made, so let's suppose, whoa, that's a little large. Let's undo that. This is going to be a little clumsy here for a while until I figure this out. Where's that eraser at? We're back in here again. Sorry, the line width is a little large here for me. All right, so we made a, if this is, you know, the storage or the hard drive, by doing int dog, an int takes up 4 memory locations, and it just reserved these 4 memory locations, let's say right here, to be called dog. So it labeled or reserved memory. And it called that memory that it just reserved for dog. There is nothing stored into it. The int is telling us that we could store, this int over here is saying, yes, you could store an int in there, which is an integer. But that's just declaring a variable. All right. Now, variable names, if we go back to what all that was on, any letter can be used. So I can use dog like that. I could also put numbers like dog3. If I compiled this, it would say, you're okay. You can name something dog3. So any letter, any number, the underscore character. I could say dog3 underscore cat. That is one variable right now. If I compile that, it'll say, hey, that's okay too. You can name a variable dog3 underscore cat. Now this is kind of powerful because in mathematics, the only thing you can call them is A, B, C, or A prime, B prime, or A, B, B. You can name your variables what they're actually storing, which is nice because eventually you'll have thousands of variables in one program. So any letter, if we're looking over here, any number, the underscore, or the $. Like I could say dog3 cat, and I could put a $sign in there as well as if I want. Now, when you play with this, like even though you can use any letter or number, you can't use any spaces. So maybe you want to, you know, call your variable the big cat. So I'm going to call this variable big cat. If I compile this right now, it's going to say, you know, I don't know what you're talking about. It tries to say you're missing a semicolon. You're like, I have a semicolon. You pull your hair out, spend hours and hours trying to figure it out. And the real problem is you can't have a variable with a space in the middle of it. So it thinks those are 2, and it's very confused. If you want to do that, you should put an underscore. If I compile that, that would work. But Java conventionality doesn't even put underscores between words. They use something called camel casing. If you want your variable to be multiple words long, all variables should start, as it says over here, it should start with a lowercase letter. All your variables, and I'm going to quiz you on that, should start with a lowercase letter. And if you want to have multiple words in your variable, then you should use something called camel casing. Camel casing says capitalize the first letter of the next word, and therefore the human eye can see that this is big cat, not big cat. I don't know. Big cat chase me, maybe, so I would capitalize that, and I would, so if I wrote a variable like this, big cat chase me, for you great outdoors, big bear chase me, big John Candy, big bear, big cat chase me. This is camel casing. Should start with a lowercase letter. The first letter of each word is capitalized. It's called camel casing because the capital letters are like humps, like Sally, and the camel has multiple humps. So we did start with the lower, no spaces allowed. You should use camel casing. You can't start it with a number. So if I wanted to put a 4 out in front here and compile this, it would say you can't do that, or it says not a statement. You're like, why? You cannot start a variable with a number because then it thinks it's a number. So you got to start it with a letter. Or let's see if you can start it with a $sign. If I do that, you can start it with a $sign or the underscore, but you cannot start it with a number. It is case sensitive. and that's very, very important. If I name a variable dog, I could later on name a variable dog, and those would be two different variables. If I compile this, it'll say, hey, you're good. Oops, ing is not a word, or not a variable type. It'll say you're good. Those are two different variables. So case sensitivity does make a difference in variables, so be very careful with that. You can't use reserved words. Now, we don't know all the reserved words. If we look over here, you can't use all the reserved words. I listed some of them, and etc. is not a reserved word. It's just saying there's lots of them. Like all these words up here, public, class. Hello is not a reserved word. That's the name of our class. But public, again, static, void is a reserved words. All these are reserved words. So if I wanted to name a variable public, I'm like, you know what? It's going to store, public people or something like that. It says, hey, you can't do that. You're like, why can't I do that? I started with a lowercase letter. I don't have any numbers. It's all good because public is a reserved word. But notice the error statement down here at the bottom does not say, hey, it's a reserved word. It's trying to do the best, but you can't name it. Now, because public is a reserved word, you could put a capital P if you wanted to, and then that would be okay because that's not a reserved word. Java has reserved some variable names already to mean something. You cannot name your variables to mean those things, or you can't have variables with the same names as theirs. So public with a lowercase p is bad. So would int, double, static, void, all those different things. All right, and the last thing on is constants. Now, we won't really use this too much, but it's something that we should know. If you want a variable to be a constant, actually, before we get to constants, let's talk about the difference between declaring, initializing, and then declaring and initializing. This is declaring a variable, and we already showed that just opens up the memory location and gets it ready, but there's nothing in it. If you actually want to put something in the memory location, so I'm going to get rid of this line of code now, and I want to put something in that memory location, I could do dog equals 4. Java stores things from right to left. This is very important. The thing on the right side of the equal sign will be stored in the thing on the left side of the equal sign. The equals operator is the storage operator, or it stores things. So this will store, but it always stores things from the right-hand side over to the left-hand side. So if I do dog equals 4 right now, it'll compile and say you're the best. I'm going to put a little comment here and say this is initializing. That's a word that we want to get used to. Initializing means putting something into a variable. We're actually giving the variable an initial value. So if we went back to what we were doing over here, there would now be the number 4 stored in there as a binary number. It would not be stored, as it'd be stored in here as a binary number, which you all know. The 1's column, the 2's column, and the 4's column. So it'd be stored as 1, 0, 0, and all of these would still be zeros here. It reserves all this room. But that would be the number that would be stored in there right now. So that's putting a number into the memory location, where this is just declaring it. Now you can do both of those on one line of code if you wanted to. I'm going to pick a different variable this time, but I could do int cat equals 4, and this would be declaring and initializing. So if you know at the time that you declare a variable what's supposed to be stored in it, you can do this third line that I just did right here. This is declaring and initializing on one line of code. You can do that. Now, there will be purposes later on this year that we want to declare first and initialize later. But if you know what's going in there, you can do it at the time that you're declaring it. You can put the number in. So this is totally okay. You can initialize on multiple lines, as it says here. So let's suppose I'm making a program that it needs a length, a width, and a height, which you're going to do later. So maybe you have an int, a length variable, and then you're like, oh, semicolon, int width variable, semicolon, int height. Well, you don't have to do that. You don't have, if they're all going to be the same type of variable, we can do them on one line of code. So int length, just know the syntax. It's a comma, and then width, comma, and then height, and then semicolon. And now if I compile this, it'll say I'm the best. I just declared 3 variables. And you can also initialize them if you want as well. Maybe you know the length is going to be 3. And you know the width is going to equal 2, but maybe you don't know what the height is going to be yet, so you leave that vacant. This is totally legal as well. So if all the variables that you want to declare for your program are of the same type, you can declare them on one line of code, initialize some, not initialize others. Kind of makes it a little bit nicer instead of having all these lines of code with all these variables. All right, now I've been using int the entire time. You're like, what is that? There are 4 major types that you need to know for the AP test. or that you need to know for this class, I should say. Int, double, char, and boolean are the 4 different variable types. Java is a strongly typed language, which means if you declare a variable, you have to tell me what kind of thing is going to get stored in there. And that goes back to chapter 1. We opened up this memory location, but when I said int dog, we set up this memory location to only store ints. So if you try to store something else in there, it would not work. So when I put the number 4 into dog right over here, when I put 4 into dog, and it put 100 there, it knows that that's the number 4, not a character 4 that really represents something else, or a programming command 4, or a color called 4. We know that it's actually the int 4. So you have to tell it what kind of thing is being stored in that location right there. Every time you declare a variable, you have to tell me what type. Now you only have to do that declaration once. So later on in the program, notice when I use dog again, I didn't put int in front of it again. You only declare the variable once, and then you can change it multiple times. So let's suppose I do dog equals 4, and then halfway through the program, I'm like, oh no, I want dog to change. Well, dog now equals 6 or something like that, because I got 6 dogs now. I don't put int dog equals 6, because I've already declared the variable once. I now just use the variable as many times as I want from here. So this will compile and say I'm the best. But if you screw it up and put int again in front of dog and then compile it, it'll say, hey, you already have a dog variable. You can't have another dog variable. And then you're like, oh no, I just want to use this one. Well, if you're using that one or changing that one, you don't put the int in front again. So you only put the int in front of the variable name the very, very first time you use it. So that's int is one type. If we go back to these notes here, we also have a double. A double is being able to store things that are decimals. So maybe the length, the width, and the height would be a decimal. So I would say double. And maybe this is storing how much money I have. Double money equals $4.50 or something like that. This is good because now it's stored as a double. Now, you should know these things as well, and you can look at the notes. And int takes up 4 bytes of information, which is very interesting. There are different ways to store integers, and int is one type. That's the only one you need to know for the AP test. It takes up 4 bytes of information, which is possibilities of 2 to the 32nd power. And there's negative numbers and positive. If you took 2 to the 32nd power, you'd get about 4 billion on your calculator. But Java will store both negative and positive, so the range of values is from about negative 2 billion to positive 2 billion. For those numbers. So that's big enough for anything that we're going to use in this class. But if I was working for NASA, I would not be using ints because the numbers would be much bigger than 2 billion. So I would have to use a different type of memory location that could store bigger numbers, which is like a long, and it takes up even more memory. A double takes up 8 bytes of information, or 8 bytes of memory, I should say. So we're going back here. So it would suck up 8 bytes. So if you don't have to use a double, some people are like, I'm just going to use a double all the time, because a double will store both ints and floating points. Like if I do double right here and I say, hey, I just want to put the number 4 in, it'll put the number 4 in there. But really it'll be stored as 4.0 because it has to be stored as a double. So a double, a variable type, will actually store integers and decimals, and floating points, or I just call them doubles from here on out. It will store decimals as well. So you're like, well, I'm just going to use double all the time. And you could do that, but you'd be wasting memory because a double requires 8 bytes of memory. And if you know something, like suppose you're asking somebody for their age. If I was asking somebody for their age, I would store it into an int. Okay, and then get it, maybe their age is 6. But this is a classic example. Money could be a decimal. So I'm going to declare that as a type of double because somebody could be storing decimals in there. Where if I ask them for their age, I'm only expecting an integer from them unless they're like 2 or 3, because then they say I'm 3.5 or 4.75. At least that's what my children did. But we're going to expect an int. So we're being a good programmer right here because we're using less memory by using an int instead of a double. So that's a good idea. The other types of memory locations are chars and booleans. We'll get to those later. You won't need any of those yet. But a char will store characters and a boolean will store either a true or a false. A char is how Unicode works. It takes up 2 bytes of information. I guess I'll show it real quick. Like char equals, to store a char into something, you use a single quote, and I would put the letter W in there. This tells me, oops, I got to give it a name. Char, I don't know, letter equals that. Sorry. So now W is being stored into this variable called letter. Use single quotes to put the letter in there. We'll talk more about that when we get there, but it sucks up only 2 bytes of memory, and we've already talked about that in chapter 1. The Unicode is a 16-bit encoding system, which is 2 bytes. And then a Boolean either stores a true or false, so I'll just show that as well. So you can say Boolean and give it a name, Boolean check, let's say, and you can give it either a true value or a false value. Notice true shows up a special cover in Java, so that's a reserved word. But if I compile that right now, I'll say it's good too. So this is storing true into a Boolean. A Boolean is just either a true or a false. We'll learn more about that with if statements. But these are the 4 types of memory or source types of variables that we'll use for this chapter. We'll only be using ints and doubles. And then eventually we'll get into strings, but they're totally different. So that's variable talk. The last thing, which I forgot to mention before, remember, or I did mention, but I didn't show you. Java stores things from right to left, from right to left, from right to left. So you have to do that. Like if I later on in the program, I'm like, oh, I want to put 12 into dog, and I say 12 equals dog, and compile this, it's going to say, what? I'm trying to take dog and store it into 12. Like, what is 12 is a number. I can't take a variable and store it in. You're like, no, I want to put 12 into dog. Well, you have to put it in the right order. Java stores things from the right to the left side of an equal sign. So this has to say dog equals 12 for this to actually work, for it actually to put the number 12 into the variable dog. So I declared dog, put a number in, changed the number, made a new variable called cat, put 4 in it, made some new variables. Now we're actually going to write, why would I need this stuff? How do I get stuff from the user? And that's what we're going to do next with the scanner class, is how do I actually get things from the user? And that's what we'll do next.